This is the presentation for the Human-Powered Compacting Trash Can project sponsored by Kohler. Our advisor for this project was John Irwin, and the department is Mechanical Engineering Technology.
Hi, I'm Mallory.
Hi, I'm Pearson.
I'm Krcmarik.
Hi, I'm Fuderer.
And I'm Mattson.
All objectives for this project was the main problem that we have seen is that vacuum trash cans tend to fill up quickly over time. The opportunity that our team was given was to create a human-powered compacting trash can for the bathroom that would increase the time needed to take out the trash in between.
To meet Kohler specifications, we have designed 3 different prototypes here. The first prototype that we started with had a different foot pedal design and a smaller liner. From there, we moved on to our second prototype to maximize the effective volume of the liner. We changed the liner design, while the arm design stayed mostly the same. However, we did change the foot pedal design to remove a part in there and get better function out of the can. Prototype 2 really set us up solid for prototype 3. Not much change between prototype 3 and prototype 2. However, we did change the fasteners on the track pieces from a glued fixture to a riveted fixture. Through this, we went through FEA testing in each prototype. With prototype 3, about a 65% increase in effective volume compared to the original bathroom slim can. We also went from a normal coil spring design to a strip spring design in prototypes 2 and 3.
So throughout our process, we chose to 3D print a lot of parts. And for our first prototype, we kind of started with a PLA carbon fiber. And so for the third prototype, we moved on to a nylon 6 carbon fiber, and we annealed it. And this material provided us the best strength and allowed us to complete more testing. For the final prototype, the design features tracks and arms that slide into the track. So as the system goes down, these arms are pushed up by the tracks, and therefore it can compress with a strip spring to return the assembly after operation.
Steps of this project, after where we've ended up, we would like to go into steps and all that. So we were working on refining the design more, things like supporting the back of this track, further testing, things like cycle testing, you just double checking anything with those refined designs. One of those things that we were planning on doing that we didn't really go into was working on designing the can so that when this drops down with too much force, it will tip the can instead of breaking it to pieces. Another thing is being working on this top here, different designs to these cast cans. You have whether rivets or glue or tape, finding one that actually works. So we had all 3 methods used, and then the next step overall was to work on scaling up this can design to other models that Kohler already does.
Thank you to our advisor, John Irwin. Thank you, Steve Ellingson, and the rest of the Kohler team. And thank you for watching the video.